The vast majority of the world, including the United States, uses centralized energy generation to power communities and businesses. Centralized energy generation, known as CEG, is defined as large-scale generation of electricity at centralized facilities. These facilities are usually located far away from the users and connected to a network of high-voltage transmission lines. The electricity generated by CEG is then distributed through the electrical power grid to multiple end users. This process, however, has come into question recently. With the large amount of land needed to build such facilities, lost energy from traveling long distances, and non-renewable energy sources currently being used, is there a new type of energy generation we can turn to? The answer is yes, and the answer is distributed energy generation. But what is distributed energy generation? Distributed energy generation, known as DEG, is a collection of various technologies that generate electricity at or near where it will be used. Instead of one big power plant transmitting power over long distances to power houses and businesses, DEG produces energy on site and can be used directly at or nearby the generation source. DEG is also very versatile when it comes to sizing. DEG may serve as a single unit, such as a home or a business, or may be part of a microgrid, a smaller grid that is also tied into the larger electricity delivery system, such as a major industrial facility, a large military or college campus, or even a small island. DEG can deliver clean, reliable power to additional customers and reduce electricity losses along transmission and distribution lines since they have to travel a smaller distance. Also, due to its smaller scale, it is more suitable for renewable energy sources. This concept of DEG is not all that new, however. Denmark, for example, has been using this system for quite some time now. Since the oil crisis of the mid-1980s, Denmark has shifted their centralized power generation system to a self-sufficient, decentralized system. Here, the majority of energy generated comes from small-scale wind farms and hydropower generation systems. This shift has been accompanied with the taxes and financial incentives for companies and towns to move towards renewable DEG. What makes DEG even more promising is the ability to use renewable energy sources for generation. For example, for small-scale residential DEGs, energy can be generated by solar photovoltaic panels, small wind and tidal turbines, and natural gas-fired fuel cells. And for larger commercial and industrial settings, energy generation can be found from combined heat and power systems, solar photovoltaic panels, wind energy, hydropower, biomass combustion or co-firing, and fuel cells fired by natural gas or biomass.
The Bahamas is a Caribbean island nation off the coast of Florida consisting of about 700 islands and keys, of which few of them are populated. The country has about 385,000 people, and 275,000 of those live in the capital island, Nassau. Eleuthera is one of the larger islands in the country. It's about 112 miles long, but it's also very narrow and sometimes less than half a mile wide. It's also home to about 11,000 people spread across a number of settlements on the island, and the island's economy is largely based around tourism. As with most islands in the Bahamas, Eleuthera generates almost all its electricity from fossil fuels. It has three main generators on the island located in the settlements Rock Sound, Hatchet Bay, and Harbor Island for a combined production of 45,000 megawatt hours each year. These generators are operated by Bahamas Electricity Corporation, which is run by the government, and all these generators use diesel, which must be imported to the Bahamas, which increases the cost of generation. Electricity in general in the Bahamas is also quite expensive. The average price is around 32 cents per kilowatt hour, compared to the US, where the average cost is about 13 cents per kilowatt hour. This high price is also compounded by the poor distribution systems on the island, and the fact that the generators are often unable to meet the peak load of about 10 megawatt hours each day, which often results in brownouts. Eleuthera's grid is set up in a radial feed system as opposed to a loop grid, and this, along with miles of poorly insulated above-ground lines, leads to high energy losses. The Bahamas in general loses more than 12% of its energy to losses, as opposed to just 5% in a nation such as the US. As an island in a sunny, windy location, there's clearly potential for renewable energy generation. The National Renewable Energy Laboratory estimated the potential generation capacity for the Bahamas as a whole at 200 megawatts for wind and 60 megawatts for solar. However, there's still little investment in wind and solar systems. In fact, as of 2009, BEC was still upgrading the power station in Hatchet Bay with 4 brand new diesel generators. A large prohibiting factor for investment in renewables was the fact that the Bahamas had banned grid-tied installations up until March of 2017. This meant that solar or wind installers couldn't sell back to the grid at peak energy production, effectively killing any commercial installations and reducing the viability of personal installations. However, on Eleuthera, there was also a preliminary grid-tied solar and wind installation by the Island School and Cape Eleuthera Institute, which helped pave the way for the eventual legalization and future renewable installations.
Due to the island's size, population, climate, and many other promising factors, we strongly believe the implementation of DEG in Eleuthera could be a potential future move for the island. We are going to perform a case study on such an implementation. We are going to examine the financial, logistical, and conceptual breakdown of how such a system would work on the island of Eleuthera, while highlighting the advantages and disadvantages of having distributed energy generation on an island.